It's the sixth lesson of theory of computation. We will go on the regular language chapter with conversion of DFAs into regular expressions. In this transformation approach, unlike the others, outgoing transitions of each state are modeled. Finally, the aim is to reach a reduced expression for the start state. In the example below, let's just focus on the Q3 state. When modeling the state for RegEx, an expression is written for each outgoing as symbol. Concatenation target state. On the right there are two rules. If the state to process is not an accept state, then the first rule is used, otherwise the second. Since state Q3 is not an accept state, we will use the first rule. In this example, to model the Q3 state, we write LQ3 variable as that. But there is a problem here. If we continue with this approach, it will create a lot of recursion. That's why we need a solution for recursive expressions. The transformation indicated by the arrow is the solution that will save us from recursive expressions. Therefore, the expressions after modeling are reduced and made suitable for this transformation. Let's transform the DFA transition diagram on the right into a regular expression. We must first start by modeling the expression of each state. Our final goal is to write the reduced expression of the start state. However, when we look at the expression of the Q0 state, we see a different state on the right. That is, we need to clean up the unwanted ones on the right. Now is the time to make some magic. When we use our solution to clean up the recursions, these two expressions will turn into expressions indicated by arrows. But since we cannot convert LQ2 to a simple expression, we focus on it at first. When we write the expression of the Q2 state instead of the variable LQ2 on the right-hand side of the start state expression, we see the expression LQ1 on the right this time. After arranging the equation we have in common brackets, we will understand that we should get rid of the unwanted variable LQ1. Otherwise, we cannot implement our recursive solution. Fortunately, the LQ1 expression fits our recursive solution. Not only that, but the obtained expression depends only on LQ0. This made our work easier. The simplified expression we have is dependent only on LQ0. Now we can get rid of all our unwanted variables by doing the recursive solution. Finally, we obtained the regular expression of the DFA transition diagram on the right. That's all. Thanks for listening.